Alright, here we go. Back into it. Segment. Alright. Cool. Okay, let's see. Jeez, okay. Here it is. Because if this were a mine, it would kill all of that, but this can't have two here because this one, so yeah. This one, okay, that means this has to be the case. It also means one of these has to be, so neither of these can be, okay. Two of those three have to be. One of those has to be. If one of these has to be, then that one can't be. Okay. And because of this situation, at least this one must be? No. I'm wrong. Ooh, wait, hold on. If this one isn't, and both of these are, but that would kill this, and that would eliminate both of those, and then this 3's done for. So actually, yes, that's it. Okay. If these are them, then I actually have to go over there. Yeah. Okay. Yeah, this has to go like that. Alright. Now... Okay. This has 4. Okay, so if this isn't a mine, or if it's not a mine, this would have to be for this row to have something, and that would kill this and force that, okay? But if this were a mine, that would kill this, thereby forcing this and that. So it is like that, okay. This 5. One of these two isn't it, so these 3 have to be. 3 mines left, so they say. One of them has to be used here. 1, 2, 1, 2, 1, 2. So all of these other ones that are out of range must be safe. Okay. Okay. That and okay. 8 by 8s. It can't be both of these, so it has to be all 3 of those. This 2. If it is here, let's say, and all of this is gone, that would just force these 3, and these 3 as well, which would then do this, which is all perfectly acceptable. Okay. But maybe this is a problem? Because it would do that, and then this would go over here. And now, what does that actually do though? No, it doesn't do anything. Oh, I know this. Because if that's on, then that's not and breaks the chain. Okay. Yeah, that's it. This would kill both of those. Yeah, okay. Okay, so there's no way this can get through. Oh, wait, no, but it could be like down here and then... Oh, I know. This 2 already has one outside the range of that one, so those 2 have to be safe. Yeah, obviously. Okay. Let's see, it can't be both of those. It also can't be both of those. I mean, if this were to happen... Yeah, okay. This 3... Only one can be... Okay, yeah, so both of those have to be. There we go. Okay, this 4... Only can have one more, so that can't be it. Oh, and that means all of these are gone too. Okay. Okay, so this is gonna have to have at least one mine in both of those rows, right? And there's no way a single one of those rows can extend past the 2. So in particular, I know anything that's over here is safe. Second of all, is this also? Yeah, because it'd have to, yeah, okay. So this as well. Okay, this has to go at least here? Because if this is going, then that's also, yeah, okay. So this has to go at least here, but that does this and that, okay. Here we go, that needs to connect now. If this is the thing, these are all gone. Oh, this can only have one more. So for example, so no matter what, this, oh, since both of these have to be, those 3 are just gone. Yeah, that's, okay. Alright, so now, since one of these has to be, it will eliminate one of those pairs, which means this guy can only have one among these 2, and therefore it needs 3 like that. 7 mines left. So let's say this. Then all of these are gone, and then these are in. This is now gone, so that's in. 1, 2, 3, 4. That is not nearly enough, so that cannot be the case. Now we have this. Similarly, this situation, 1, we need 6, and that has 3, so 3, okay, 1, 2, 3. Okay, yeah. Okay, if one of these rows gets cut off, the 5 cannot operate, so... Okay, and then this has to go all the way to there at least. This 4, one of these will have to be, and that will cut off those, so that means all 3 of these have to be. Right, and either way this can't be. Okay. how does this change anything? What? Oh, because of these existing, these have to go all the way to there. Yeah, okay. Okay. So that can't be it, because that would eliminate both of those. Oh, and that's all? Okay. This is gone, that's in, that's out. 3. This 3 says, if this isn't a 1, then that's gone 1, 2, 3, 4, 5. Okay, that is allowed. But obviously that isn't. Even if this isn't, you have this, then you could, yeah, okay, there's possibilities here. What about this though? That would force that. This has 4 already. That's a problem. Okay. Does this cause a similar problem? Oh, but this would, wouldn't it? Yeah. Okay. 3 mines left. 2 in range of the 3, 1 in range of the 5, and or other 3. Therefore, these are safe. Therefore, oh boy. If only one of these 3 is, that means this one has to be, and it also means that one has to be, which does this, which now, okay. 6. Okay, so for example, if this eliminates these, that would force all of this. Okay, so that's not quite impossible. But this, for example, there's no way this would be able to reach over here, because if it tries to go this way, it gets blocked by the 2. And so that would eliminate all that, which is definitely not allowed. So 1, what? Oh, jeez, okay. 1, 2. And since mines have to be over here as well, that means all of these as well. Now, if this, no, that's fine. Oh, these 2 can't be, so 2 of these 3 have to be, which means there has to be something here, so that's gone. And furthermore, if 2 of these 3 have to be, that cannot be empty. And I guess for similar reasons, these can't be empty. Yeah, okay. So if this is a mine, it would force those, which would kill both of these, and then this 4 would be done for. So, no. So if this is a mine, these are all gone. Everything is kind of fine. Okay, first of all, it does this. This 2 needs 1 more. In particular, that's impossible, so this has to happen. In a similar fashion, if this is a mine, this has to connect up to there. The 2 is now satisfied, and these are gone, and that's forced anyway. So 1, 2. And this is also gone. And I think this one always has to be a mine, regardless. Yes. Okay. This 4. Okay, so there has to be a second one here. The 4. Oh no, there could be all 3 here. Yeah, but either way, this would cause a problem. Yes. Okay. Therefore, this. Okay. Because this is a mine, it kills both of these, but that's fine. Oh, yeah, this segment. Okay. Oh, this 4. Only one of these could be, so all 3 of these have to be. Alright. 3 mines left. Those 3 are all around the 6. Anything not in that 6 is now safe. This 4 says that happens, and that means this side needs a segment. Okay. And that was 8 by 8, right? 3? Okay. Next variant. Product. Clues represent the product of the distance to the nearest 2 mines. So you get the 2 closest mines to it. You look at their distance according to the Pythagorean theorem, right? A squared plus b squared equals c squared. Good old thing. So this one is a distance of 2 vertically and 1 horizontally. So it's the square root of 1 squared plus 2 squared, which is the square root of 5. And this has a distance of 1, so 1 times the square root of 5 is the square root of 5, as we see here. So this is like the math variant. Alright. Oh, another screen to show this happening. Because 2 could be like the square root of 2 times the square root of 2, or 1 times 2, right? So a lot of there's combinations of things that can happen. Alright, yep. Alright. In particular, this 1 will force a second mine within 1 distance of itself, which means this 2 will have a mine that's within 1 distance of itself. So 1, it can't have something that's the square root of 2, because the only way for the square root of 2 to multiply to 2 is to have 2 mines that are the square root of 2, but there's only 1 space for a square root of 2 next to it. So one of these is a 1, the other one's a 2. In particular, this can't be, because if this were, that's a distance of 1 from this 2, and this 1 would force another thing that's a distance of 1 from the 2, and 1 times 1 is 1, which is not 2. And so that is not allowed. Alright. Now, for example, if this was a mine, then this 2 here would need its second closest mine to it to be also the square root of 2 distance away from it. But that will then put 2 mines that are a distance of 1 away from this 2, which would make it 1 times 1, which is not 2. And so this cannot be a mine, and therefore neither can that. And so this mine has to have 1 there, and that mine has to have 1 there. So this 2 is now done, because 1 times 2, and same with this one, 1 times 2. As long as there aren't any closer mines to it, which there aren't. Okay. Now this 2, wait, what? Oh, this can't, wait, why couldn't that be? Oh, this already has a square root of 2, so one of these 2 has to be, but that 1 covers that. Okay, this square root of 2 needs a 1 times the square root of 2, so it has to be like that. Okay, now this 2 root 2. Okay, so it had a 2 next to it already. So it had to have a square root of 2 to get 2 times the square root of 2. I think that was the reasoning there. This could get like a 1 and a 2 root 2, like that distance, but this was closer, so it couldn't have a 2 times the square root of 2. So that means the only combination possible, because of the 2 already existing, was a 2 and a square root of 2. And then this thing already has a 1, so it needs a square root of 2, which is that one. And so this one is gone. And, oh, same deal. Okay. Alright, so this square root of 2 needs a 1 and a square root of 2. That's the only way to deal with square roots of 2. So that one has to be. And one of these 2 has to be, but only one of those 2 can be. Because if both of them are, then this square root of 2 has a 1 and a 1, which multiplies to 1, which is not the square root of 2, it's 1. Okay. So if, but this one forces at least one of these 2 to be, and so if this one is a 1, or is next to this, and it would be one distance away, then it would force two one distance away mines, which is not allowed. So that's not a mine. Okay. This thing needs a mine that's square root of 2 distance away, which is right there. Okay. This one needs two mines next to it that are a distance of 1 away. But it can't be both of these, because those are both one distance away from the square root of 2, and you can't have two mines that are one distance away from the square root of 2. So therefore this one must be a mine, at least. And that also means that neither of these can be, because one of these has to be, because you can't have two. Okay, there's that, here we go. Things are happening. One of these two is, so that one isn't, so there we go. Okay. 2 and the 2 times the square root of 2. So let's assume that this one is a mine. So this means this 2 needs one mine that is a distance of 2 away from it to go with the 1, and it cannot have anything that is closer than that. So anything that's less than 2 distance away cannot be a mine, which is all of those. And furthermore, it needs one that is distance of 2 away. So that is here or here. The problem is this 2 root 2 also now has one that's one distance away from it. And, well, that means its other mine has to be a distance of 2 root 2 away from it, which would be over here. But this 2 forces one to be closer than that, and so it would have something that would like violate the rules, so these are gone. I think the other option is probably this. If this is not a mine, or if it is a mine, that's a 1 distance away from this thing, so everything that is closer than the distance of 2 times the square root of 2 must not be a mine. 2 times the square root of 2 is like over here and over here, by the way. So everything closer than that has to not be a mine. And now we can get this one, perhaps, and now this 2 has one that's a square root of 2 distance away. But everything else is now farther than the square root of 2 distance away from this, and so whatever mine is next closest, well, actually, it's probably going to be this one, because that's already square root of 5 away from this, which is also what these 2 are. So these are the 2 closest mines. That multiplies to the square root of 10, which is not 2. So neither of these can be. Okay, there we go. Oh, we have a square root of 10. Isn't that great? Alright, so if this is a mine, that's a 1. So that means you need the thing to be square root of 10. The closest mine to this, other than that one now, would have to be the square root of 10 distance away from this thing, which is 3 squared plus 1 squared is 10, right? So you need to go 1, 2, 3 in one direction and 1 in the other, so that's possibly 1, 2, 3, 1. Those locations? Yeah? Okay. That means everything else that's closer than that cannot be mines. Okay, so this 2 root 2 has a distance of 2 away from it now, and so it needs a distance of the square root of 2 to fix that. So that's the one that is the mine. Now this square root of 2 has a 1 next to it, so it can't have another 1 next to it. This 2 already has one that's distance of 2 away, and that means it needs a distance of 1 away. So actually, this is possible, and it implies all of this. Interestingly enough. Okay. So how about something like this, though? This now has a square root of 2. So now the 3 options are those again, but it can't be here, because that would violate this 2 root 2. This 2 root 2 needs a 2 distance away. But again, everything within those distances from the 10, or the square root of 10, are gone. So this needs a mine there. Okay. This now has a square root of 2. Would force this and take these out, thereby forcing that. Wow, and then just one of these two has to be, and that would do the job. So that's also possible. I think for similar reasons it could be one down here as well. But in all such cases, all that other stuff is okay. But I guess the point is, alright, what about this? If that's the square root of 2, the next one needs to be square root of 5, which are here and here. Those are in fact the only places those are. Now, the way I see it, this guy right here, this is the square root of 5 away from this thing, right? But the square root of 5, like, you can't multiply it by anything to make it multiply to 2 times the square root of 2, or at least not any like distances that you can achieve on a grid like this, right? So that means the 2 mines that are closest to this one cannot be this guy. So it has to have 2 mines that are closer than this. Oh, this is also root 5 away from that. So in particular, it needs to have, it can't have a mine that is a distance of 2 times the square root of 2 away, because that's more than the square root of 5. And if, so that will not be able to be included in its product at all. So that means its only option is a 2 and a square root of 2. So it needs to have a square root of 2, which is that one right there. And then since this is gone because of the square root of 2, there needs to be one here as well for 2. So this one is now done. This one is fine, square root of 2 times square root of 5, or square root of 5 over there, whatever. Okay. Now this 2 has a square root of 2 here, so it has to have one there, and then this happens. Okay, so that's also possible. Jeez. Can I say the same about this square? Yes, I can, actually. Wow, I just got nothing from any of that. Okay, so how about this? I would kill this and all of these and force 2 distance away, which would be one of these 2 things, right? One of those 2. That means this would need something 2 distance away as well. But this can't have anything square root of 2. Oh, okay, so that's forced, because this square root of 2 needs a 1 next to it. And now this 2 root 2 has something that is root 2 distance away. So it needs something 2 distance away, which the only thing left for that is this, but that's a problem, right? Because now this square root of 10 has a square root of 5 and a 1, which is not good. So that cannot be a mine. Okay. Do similar things happen here? This is now square root of 5 away from that. This also kills all of these square root of 2's here, so this root 2 needs those 2 to happen. So this needs something 2 distance away, which would be this. But then, again, we have that problem, don't we? Yeah. Okay, so that's not it either. And that means this needs 2 out of those 3 squares to be mines. Wait. Didn't I say this one forced like all of this to be, that's also, no, that's square root of 5 away. So no, it needs something like that. Oh, and that's 3 away. Oh no, this is just done for. No, this can't work. What the heck? How did I think that could work? Okay, whatever. Okay, this thing will force one of those 2, right? Or both, potentially, even. Okay, this would kill that, which would force both of these. That guy's fine. This is a square root of 5, so it needs a square root of 2. But a square root of 2 that is farther away, so one of these guys, actually. In particular, these are gone. This is fine, this needs that. This just needs one of those two, and it's fine. Yeah, okay. What if this isn't? Then it forces that. That's now gone. That's in. This guy needs. What does it need? Okay, it has a 2. So it needs a square root of 2 now? Yeah. Which should be one of these. But then this would need a square root of. Oh, it could go there or there, I guess. Or even. Wait, no, this has one within 3 distance. So actually. Yeah, okay. This is now root 5 away from this, so it cannot have 1, so it has to have a square root of 2. This already has a 2, it needs a square root of 2. Okay, okay. Alright. Ugh. Yeah, no, this one probably will take a while. A lot of math going on here. Okay, 2 root 2. So the possibilities for that are 1 times 2 root 2, or square root of 2 times 2, right? So, first of all, if this is here, this is a 1, so that means anything closer than 2 root 2 must be safe. So the mine could be out here, out here, out here, or out there. Anything closer than that, and this entire thing is gone, that means this 1 is just done for, because it needs 2 next to it that are mines. Like 2 specifically have distance 1 away, but this disallows both of these, so it only can have one thing that's a mine that's 1 distance away from it. So it would have the square root of 2 as its distance, which is not allowed. So the same thing would happen for all 4 of the 1s next to this 2 root 2. Okay. So this now needs a 2 and a square root of 2 next to it. And it can only have 1 square root of 2 next to it. So, for example, if this is it, then these are all gone, and it forces both of these in. This 2 now needs, well, okay, now square root of 5 is fine. Away from that. This 2, no, everything's kind of fine. Well, that's gone. Yeah, no, this is okay. If this isn't, well, oh wait, no, that's not what I'm looking for a safe square. Okay. This is interesting, I guess, because they would eliminate all of this, but would also put a 1 on these 2s, which would take away everything closer than that from them. And this guy would need specifically one that's 2 distance away, but it doesn't have any such open squares, so it is this one. So let's see this. That is now a square root of 2 distance away from this, forcing that, taking that out. This now puts this in this position. This 2 needs 2 distance away, so it has to be like that. This now only has 1 square root of 2 next to it, so it can't use that. It has to use this. This is gone. Okay, this one's fine. This one requires that. This needs 2 distant away, which it can easily do. This also needs 2 distant away, which you can easily do. This one's fine right now. Okay, so this is all okay. So if this is not on my way, that had to be safe. Yeah, I just didn't like it. Okay. So now there's several ways for this to work. Well, okay, first of all, that is now not a mine. This guy needs a 1 and a 2. The only distance 2 it has at its disposal is this one, so it has to be that. And that eliminates all of these, which puts that in here. And now this has a square root of 2, so that has to be like that. But this already has its root 2, so that can't be, so that means that has to be. And now I have all 4 spots. 1, 2, 3, 4. I really expected to have to like make other assumptions with this, but this turned out to imply a lot of stuff, which is interesting, but okay. It's not what I was expecting. Okay, this 3, with the current yellow arrangement I have, there's a 1 and there's a 2. And that's just not allowed. So this 3 is contradicted by the fact that that isn't a mine, which means that one is a mine. What? Oh, that's 3 away, not 2 away. I'm stupid. Okay, no, that was completely fine. Alright, well, jeez. Okay, yeah, well. What did I get? It was this, and then that was the one, and then we got like 4 spots. It was this weird argument in cases, like 1, 2, 3, and this is a mine, then that can't be, but if this isn't a mine, then it has to be, yeah, it's that one. Okay. So if this is a mine, this 3, everything closer than 3 distance away must not be a mine. This needs 1 of distance 2 away. Well, this needs this, which, okay. Yeah. This needs that now. And this, therefore, needs this. This is gone, but this one, oh, well, this one just kind of does that already. This one's fine. Yeah, no, this is a valid arrangement. Okay. Now the other way. That forces what? If this is gone, that's gone, and then this is in and that's in, and then this needs that? Wait, what? Hold on. This? No, it already has that. It's fine. No, because this has this, it has to have that as well. If this is gone, but this is here, that's already covered. So why does... Oh, right, that's a different arrangement than I'm thinking. Okay. And now everything is fine here. But everything here contradicts all the other stuff. This guy... Oh, it has that already, so it's fine. This 2 is good, this 3 is fine. Well, I guess it technically kills all those. Oh, so that's just it. Okay. 2 times the square root of 13? What? Okay. The square root of 13 is 9. 13 is 9 plus 4. So it needs 2 distance away in one direction and 3 in another. If this has the square root of 2, I guess you could get like the square root of 26 is the other distance, which is like 5 and 1. But and under this arrangement that I have marked in yellow right now, that is the closest mine, and then that's the next closest. This has square root of 2, and this has 1, 2, 3, 1, square root of 10, which is the square root of 20, which is much less than the square root of 52, which is 2 root 13, right? So anything even closer, which like that could happen, and that would make this not the closest, it's not the second closest, but that the second closest instead. But like, it's not working, right? So like that is gonna, well, anyway, I can mark all the things that I had in red. What? But I had a red there. Is that not? Oh, maybe because, no, but this too needed, no, yeah, it does. Oh, but it already had that. That's what my mistake is. Okay. All right. 1, 2, 3, 4. 1, 1, 2, 3, 4? Yes, okay. Those are gone, that's gone, that needs those. Okay, here we go. I remember this being a thing, and then I guess everything else will just follow from that. Okay, there we go. Alright. 5. 5 is a prime number. So it could be the square root of 5 times the square root of 5, or it could be 1 times 5. So do we think the 1 times 5 option is possible? Let's see. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So that's the only other place, and everything closer than that, which 4, 1, yeah, that's closer than 5. So it's gonna kill everything here, like this. Right? Okay. That poses a problem for this guy, I think, because it needs the square root of 2 or 2 times the square root of 2, which now it can't get either of those, so that means these are gone. Okay. And then you need 2 root 5s, which are just those two. Yeah, alright. Okay, 2 and the square root of 2. Oh yeah, okay, because this 2, it could be the square root of 2 times the square root of 2, but it would need 2 squares that are distance of square root of 2 away from it, which it wouldn't have in this case. Well, it doesn't have in this case. There we go, okay. So that's a distance of 2, so it can't have 2 root 2 times 1, because it already has 1 distance 2, so it has to be like that. Okay. So what happens? Oh wait, something forced to be a mine. I need one of these 3 to be a mine, right? Ah. Oh, but it needs a distance of 2 away, so one of those 2 has to be. Either this one or that. Oh, no, this root 2 needs something within a distance of root 2 from it, obviously. Okay. Yeah. Now that one of these 2 needs to be, we can't have that being 1. Okay. This needs a root 2 and a 2, because it already has a root 5, so it definitely cannot have a 2 root 2 times 1. It also, which is why that square was marked for me when I clicked that, probably. Okay, so what cannot be a mine? If this is a mine, that's gone and that's a mine, that's actually completely fine. But I guess if this is a mine, then both the root 2s of this guy are gone, so that's not allowed. Yes, okay. This root 2, we'll do that. This, okay, sure, yep, okay, alright. What? Oh yeah, alright. 2 root 5, what? Because 2 root 5 is a 4 one way and a 2 the other. 1, 2, 3, 4, 1, 2. Ah, so it has things closer than that, so it can't have something distance of 1 away. That's why those auto-filled. Okay. Now, 2 root 5 can't have a square root of 2 next to it, right? Oh no, it could be a square root of 2 and a square root of 10, and that would multiply the square root of 20, which simplifies to 2 root 5. So actually that is possible. But let's just say that's a thing. Okay. So then I need a square root of 10, which is 1, 2, 3, and 1. 1, 2, 3, 1. So that's the only square root of 10, and everything closer than that must not be a mine. However, what this does is a 1 and a square root of 5, which is no good, so get out of here. Alright, you are possible, right? Because that's a 2, so this just needs a root 5, which could be like one of those 2. Oh, but yeah, there's no way, because this has a 1, so it needs like a 2 or 2 next to it, which is like over here, which if everything closer than that's eliminated, this 2 root 5 is not having the right things happen. Okay. Oh. Okay. It's autofilling. Let's just skip the math. Let the game do the math for me. This has a square root of 2. It needs a 2. So one of those 2 would be the 2 that it can get. So this will already have a square root of 2, so it can't have another one. It needs a 2 next, which it already has, by the way. Okay. This has a 2 next to it, but there are 2. Okay. So if this is a mine, it would force this one to be as well, but this is now 2 times the square root of 5, which is not 2 times, or 1 times the square root of 5, which is not 2 times the square root of 2. So that's gone, therefore that's gone. This needs a square root of 2 and a 2, which it will be one of those two. But that doesn't necessarily mean it still can't be that one, because you can tie for longest distance, and that's no problem. Ah, but this 2 says that that one can't be, which means that has to be. Which, okay, we're done. On to 7 by 7. 45 minutes in, okay. Right. This, oh. It can't have 2 or the square root of 2? Right, because neither of those could multiply by something to get the square root of 5. Right, okay. This 1 says that, well, one of these has to be, and that has to be, and that means, yeah, no, that's fine. Okay. This 1, well, 2 of these have to be, okay, so one of them has to be the 1 next to the square root of 5, and the other has to be the square root of 5. So in particular, like if this were a mine, then these would be out, so this 1 would need both of those to work. And then the square root of 5 would be like, I just need one of those. Or, well, I already have one of those there, right? I can't have it any closer, like, it's completely fine. But this 1 needs one of those guys, right? This root 2, though, would say, oh, well, those can't be mines now, because I already have one of distance 1 next to me. And now I need a square root of 2, which would be one of those. And this 2 would be like, I need something distance of 2 away, because I already have a distance of 1, so that does this. Now this 2 is like, well, one of these has to be a square root of 2. So that means all of these are gone. And so I need one square root of 2 over there, but I don't know which is which, right? So there we go. Let's mark it. No, I didn't mean to erase red, I wanted to erase yellow. Okay, another possibility. Let's say this isn't 1. Then maybe this is instead. Well, then this is gone because of this 2, and this is gone because of that, and then that means that has to be there, and so both of these, but that's 2 on the square root of 2, so that's actually a contradiction. So if that isn't 1, then this isn't either, and so it has to be that, which will now eliminate, wait, what does it eliminate? Hold on. This 2 will need this to happen, for sure. This, oh yeah, the square root of 2 eliminates all of this, which now forces this in. Square root of 5 is happy, the 1 is happy, this 1 is happy, this 2 is happy. This square root of 2 will need one of these, which will also force these gone. And now we look at the overlaps. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. How much of this do I erase? Should I try to keep what remains undetermined in my deductions and see, oh, the 2 possibilities we're looking at are either, that's not that much. Okay. The square root of 2, since I know one of these has to be, that can't be, oh, because it could have been both of those. I'm dumb. Okay. What? You. Okay, and then this, and it was like, that was safe, all of these were safe, 1, 2, 3 mines, and, okay. So either, yeah, so that, okay. We are back. Oh, that would just give me that, which does a lot of stuff. Okay. Yeah, I did, okay. Sure, let the game do the work for me. Alright, yes. Do that math game. Okay, what? Oh, this too needs that. Okay, yeah. Okay. Alright, that, and therefore this. Okay. Oh yeah, obviously. Yeah, okay. This needs, okay, this and that, and then, what do you need? You need that, yes, okay. These are going to be 1, so it can't be that, and this has to have one of these? Yeah, but which one? Who knows? Okay. This guy probably is the key to the next step. So if I have a 1 here, right, then, like, everything closer than 2 root 2 has to be murdered. And then this guy is like, what do I do? Yeah, okay. So, just, yeah, okay. And now that forces this, okay, naturally. This needs a 1 to root 5 potentially. However, if you have this, oh, then its root 5 just has to be there. In particular, if this is the root 5 to this guy, and then it needs a 1, this has a root 2, so like it kills both of those, because it needs a 2, which is not the square root of 2, right? So we just can't have that. So we have this, and then this does that. Now that's a 2, that'll be a square root of 2, that's completely fine. Okay. Oh, that 2 does something, and it tells me stuff. Alright. Alright, cool. Yep, sure. Alright. Ah, nothing is automatic. Alright, this one needs 2 of these 3 to be mines, which means at least one of these is, and that means that one is, and that means neither of those are. Okay, easy. Okay, this root 2. Well, you see, this needs... Okay, but... Is this a problem, for instance? No, not really. Well, okay, what about like this or something? I don't know. No, it doesn't really seem to be a problem. What about this? That would kind of do a lot of stuff, right? Then this would happen, and this 2 already has 2, so it needs a 1, but like... But this, okay, would do that. And this needs, yeah, but this, okay. Oh, hello. There's no square root of 2 next to that, so it's over for it. Yeah, cool. In particular, if this isn't a mine, it forces this to be, which kills that, so like this has to be. Alright. And that kills that. Okay, cool. Isn't that nice? That still could be. That has to be one of those. This is the square root of 2, so it kills all of those. This just needs another root 2, but that's fine. What? Oh, it needed that, and so, okay. Alright. Thanks, square root of 10. You told me a lot of stuff. Okay, cool. Okay, we got 8 minutes to do 3 boards. Think we can pull it off for 8x8 product? Boy. Okay, this one says at least one of these 2 has to be, so these 3 are gone. Okay. Okay, same deal? No, not the same deal. Okay, no. Okay, what about this? Then this is all happening. And now, like, these are all gone. This is fine, these are fine. This thing needs a 2 distance away, that's the only option, and this needs a 2 distance away, and that's the only option. But now this one would be forced to be like that. Maybe it's this interaction here that I should be looking for. I don't know if this cluster of stuff would be any good. I mean, maybe, but we'll see. This, okay, if this is a thing, then these are out, and one of these 2 has to be. But this needs a square root of 5 as the closest, so it has to be like that. And so it would be like this, and that's fine. On the other hand, this would kill everything that is less than the square root of 5 distance away. Which is just that. So this would force this, and then I guess, well, many things could happen. Okay. Never mind. There's not really much I can do about that. Wait, that's square root of 10? Hello? Square root of 10 is 3 and 1. 1, 2, 3, 1. So it could be here, and it could be there. So actually, it would be this. And then these... Which is actually fine for this guy. But you know what isn't fine? Is if it's this, and then that's the only option, right? Yeah, everything here is closer to it than that, so goodbye. But if you have root 2, you could also have root 5, which would do that. Okay. So if this, and then it's that, right? And all of these are gone. 1, 2, 3, 1. Yeah, that's going to. But if it's this, then we need square root of 5, which would be one of those two. Which, it could be either of these. So you could have that arrangement if you want. You could have just that, and then, like, yeah, so it tells me nothing. Okay, so I have to look at this area. Oh boy. I guess we're gonna redo all of that stuff here. Oh wait, no, that's not how that works. First of all, I wanted to assume that that's not a mine. And then look at all the consequences here. This would kill all of this. This has 1s next to it, so they can't have root 2 distance aways either. This guy is fine. This... Oh, it could go down here for where its mine is. But this one for sure only can go here. The point is those are both... Oh, hold on, this one. It's, yeah, this square is not allowed. So this one is just done for. Okay, so that's a mine. Alright. Obviously you can't have both of these. You can't have both of them. Yeah. So, like, what about this? That would eliminate all of this, which would force this to happen, of course. And now this would be gone. This 2 can't have any square root of 2's, and neither can that, so now this 1 is done for, so goodbye. So now there's 2 options. This could be here, because this 2 needs one of those 2 to be, which would eliminate this, which would force this, which now this needs square root of 2's, which means we have that going on, which forces this, and oh yeah, no, it's fine. Okay, so that's one way. I mean, this whole cluster is symmetrical, so I could just do like a mirror symmetry along this diagonal line or something and look what matches, but that's an empty, right? Yeah, it is. Okay, this has 2 there. Alright. So the other situation is that this happens, which forces that, which then kills this. Yes. This would now be forced to have these, and this would be killed as well, forcing that. So we have 1, 2, 3. Square root of 2. Hello. That means this, which means one of these 2 has to... But that forces that. Yeah, okay. What else got revealed? This is a 1. So that is required, which will probably imply all the other stuff that I had marked. Okay. Okay. Alright. We can do one more. Which means there'll still be 1 left next time, but that's not that bad. Okay. This 1 needs at least 2 of these, so this 2 just needs both of those. Okay. Because if one of them is, then both of them have to be, because those are the only 2 things that are distance of square root 2 away from this 2, and it needs 2 square root of 2's to make a 2. Alright. I think the same thing happens with this 1 and this 2. Yeah, it does. So, what? Oh, because it has another square root of 2 away from it. Something slightly different happens. First of all, this square root of 2 here, it can't have both of these, so that one has to be, and neither of these can be. Also now, this 2 can't have anything next to it. There we go. But it could have one here, and then the second mine of the 1 could be there. So I was slightly off in my reasoning there. Okay. Yeah. Just allow everything to propagate. Oh. Uh-oh. We have to think. Okay. This 2 could have one of those 2 options. This square root of 2 already has a thing. This can't be both. But this... okay, this maybe would say some interesting things. Yes, this 2 is now dead. Okay. If this is gone... well, now that forces one of those 2, so this guy is fine. But I guess the point is, this guy needs one in one of these 2 spots, so that one can't have them there. Okay. Cool. Excellent. Okay, well, we did go over an hour, but that did only take, like, we only barely went over the hour, right? But we still got one more end product. Okay. But yeah, that is the hour. Alright, so we're out of here. Oh, this is right here. It's so tempting, but okay. The E is very interesting mode, I'll just say. Alright. But, of course, I have to do the G first, and then I can get to the E. I wonder if we'll get there next time or not. We'll have to find out. Alright. That's it for today, so thanks for watching. Void out.